Good morning, everyone. Thanks for coming. My name is Jimmy Bogard. That's all my details up there if you want to connect me. Probably the best way to reach out to me, though, is LinkedIn these days. That seems to be where everyone's moving in terms of like the socials. Today's talk is just an exploration of my journey using Aspire over the past 18 months to 2 years. My day job is as a consultant. And so a lot of times I'm presented with situations of like very difficult environments, difficult applications, and the applications take a long time to get up and running. And this is something I see over and over and over and over again, where I'm a new developer, a new consultant coming onto the team, and I want to start to be productive because I'm charging per hour, but it takes a long time for me to be able to clone and run the application. And this metric I've heard over the years, also known as time to login screen. That is, when you have a new developer come on board, how quickly can that developer download the code and then run it to launch up that login screen, right? The first screen that always pops up whenever they launch the application is like the login screen. So how long does it take for the developer to get there? And what I found is that the more effort we put into shortening that time, not just to launch the initial login screen, but the work it takes to make sure my local dev environment is really easy to get up and going, the easier that is, that also means that the local dev loop, that is, make a change, see it in action, and then make those iterations very quickly. If I put more effort into making this time go down, then I find that I'm able to deliver all the features in my system more quickly. Now, over the years, I've used a lot of different kinds of strategies to make this number lower. Things like, we'd make sure that we had a local build script that would, like create the local database, fill it with test data, and all this sort of stuff like that. And so I've had a lot of kind of very bespoke, customized sort of solutions for this over the years. But what I found with Aspire is Aspire aims to try to solve a lot of those problems. So in this talk, we will be looking at what Aspire is, what problems it solves, what problems it solved for me in particular, because like any tool from Microsoft, they're going to say it solves 18,000 problems, but you're like, really, does it? And so I'll be talking really about the things that it solves for me personally, and I'll just not talk about the things that I've never tried to use before because it just wouldn't work in my clients. We'll talk about some of the basic building blocks, and we'll also look at how do I take existing applications and existing systems and then introduce Aspire into them. A lot of the demos from Microsoft will often be like file new project, and then now I have this greenfield set of infrastructure that I can start applying all my stuff to. That's not the reality that I live in. I'm almost always dealing with existing systems, existing applications that we're trying to modernize. And so I found that Aspire is still able to be used in those kinds of environments as well. So let's cover a little bit about what Aspire is first, and then I'll start immediately. This is like a very code-heavy talk, so I'll go into demo very quickly here. So Microsoft says from their docs that Aspire streamlines building, running, debugging, and deploying distributed apps. Now, of those 4 things, I've done the first 3. I have never attempted to use Aspire to deploy anything. And the reason is that my clients and their environments are usually much more locked down, and so infrastructure components are usually going through a different process. So if I need to provision Azure resources, provision AWS resources, I'm not using some just C# tool to do so. It's going to be some kind of infrastructure as code tool, and it's probably having to go through a different pipeline, different set of approvals, all that sort of stuff. So maybe this deployment could work for you, but I've never done it before, and I probably will never do it, so I'm just not going to go through the deployment aspect. If you want to go look in the deployments, that's fine. It can generate Bicep and Terraform and stuff like that. But again, I usually have a team that's dedicated to those kinds of activities, and so I've never been presented with an opportunity to even try to deploy something like this anyway. It's very much reminiscent of right-click deploy, where you could used to do that in Visual Studio, just right-click the thing and deploy it out to Azure. And that's a very, works well in demos, but then real systems and applications, you're not probably doing that. So I won't be covering deployments, but it is a thing that exists. One of the other things I saw here is that Aspire originated from some other distributed system orchestration tools. So if you've ever heard of Project Pi or Dapper, Aspire is the spiritual successor to those things. And initially, it was very much marketed as something that would help you build distributed apps. Like I've got 16 apps with microservices, and they all got to be connected together, and this Aspire will help you with all those sort of things. But what I found is that Aspire is not just for like complex distributed systems. It's for apps of all shapes and sizes. So if I have anything past a single API that has any other resource, then I would use Aspire for that as well. It is not just for, I've got microservices and all these sort of things going on. If you've got an app that talks to anything else, a database, storage, whatever, then Aspire is for you as well. So we're going to go straight into our demo here. And I'll start out with just the kind of basic, building blocks of Aspire here. So I'm just going to first start out by creating a new API, but not introduce Aspire yet. And we'll see how Aspire layers on top of existing applications. So I'm just going to say File, New Solution, and we'll call it NDC London. And it is going to be, oh, no, we'll just start with an API. Just a regular web API, nothing very exciting here, just the stock template here. And then we'll add Aspire on top of this. Now, to actually use Aspire, there's not a lot of components that you need. Aspire, behind the scenes, uses the .NET 10.0 SDK to run the Aspire host, which we'll be looking at here in a second. But it doesn't require that all your applications be .NET 10 or even .NET at all. So we'll be looking through some of those other kinds of things as well. But just for this demo, we'll just start with a .NET 10 API. All right, so I've got, just a API that probably does what, like weather forecast, of course. And are you going to launch the thing? Oh, it did not launch the browser. OK, well, we'll look at here in a second the actual API. But this is just a simple API that does like basically nothing here. And so what I want to lay on top of this are the Aspire building blocks so that we can start using Aspire to orchestrate different services together. The two main components of Aspire whenever I'm using it in local applications, one is going to be an application host, and the other one's going to be a set of service defaults. So I'll add those two projects as well. Oh, look at that, add Aspire orchestration. Yes, do the thing. So what did that do for us? That added a new project down here called the app host. And this is the Aspire distributed application host. This is the host that will then orchestrate all the different resources together. And it's kind of analogous to what we used to use Docker Compose for, except Docker Compose was typically used for just orchestrating dependencies, not necessarily orchestrating the services and applications together as well. You could use Docker Compose for that, but then that also meant that you had to run everything inside of Docker. So that's the other thing that Aspire requires, is it requires the .NET 10 SDK to run this application host right here. It's using the app host SDK, and it's .NET 10. And then the other thing it needs is some OCI compliance Docker runtime. So you can use Docker Desktop, of course, or if you want to use Podman, as long as it's OCI compliance, you can use that as well. Aspire uses an OCI compliant container host to run any of the dependencies that you want. So if you want to run a database, cache, whatever, that's going to be run through Docker, but orchestrated through Aspire. All right. So the next piece we have here is this other service defaults project. It's kind of a weird one here, but the service defaults adds some configuration to our hosts that actually are running the APIs and applications to make them kind of work better with Aspire and the orchestration. So it'll do things like enabling service discovery. So if I have multiple APIs that are talking to each other and I want to have them be discovered and have the host names automatically injected in, that's what the service defaults does. It does a lot of other stuff, which we'll get through here in a minute. But this service defaults project, before Aspire, I would typically have some common project or even a common NuGet package that pulled together all the common service configuration across all my services I was deploying. So all the common like logging, tracing, telemetry, exception handling, service discovery, the things that are not really specific to any one individual project, you probably have already pulled that code out to somewhere shared that then would be used across all your services so they kind of all have the same configuration. That's what that service defaults project is just the common service configuration that as we build more and more complex systems, I'll just keep modifying that as we go. And in kind of real-world applications, either that project is part of the overall solution with all the different systems, or we've separated it out into its own repository, its own project, and then published out as a NuGet package for all my different systems to consume. And so the part that changed in my API project here is this line of code right here, this builder.add service defaults. That's what's adding all the common service configuration. And if you look inside of it, it's, again, not that exciting. It's doing like health checks, service discovery, HTTP client defaults. It's a lot of the same junk that I would see over and over again, just now like pulled into a top-level package. And this service defaults is just a library. That's all it is. Nothing very exciting here. So that is the extent of the changes to my API project. Now I'm going to switch over in here in a minute to a more real-world application with databases and message queues and all sorts of other fun stuff. But for right now, all you see that's changed in this application, this API, is just builder.add service defaults. That's it. Now the next piece we have is this application host. The application host is an application that is only run in your local dev environment. Like it only runs on my laptop. I never deploy it. I never package it. Nothing. It is just a application that orchestrates all the different resources and dependencies together. And the way we express that, those connections and what services and resources we want to use is not YAML. Yay, not YAML. It is C# code, just plain C# code. I'm always like a reluctant user of YAML. When I'm using Docker Compose, I'm like, okay, this is what I have to use because it's the only thing available to me. Or sometimes, oh gosh, if I'm using Kubernetes, then it's like OpenTofu, something, something, something. Or that's Terraform, never mind. Anyway, so it's like all these other systems, these orchestration runtimes use this markup language that is not very conducive to like more complex things you might want to express. And so Aspire takes that one step further and says, why don't we just use code? Because code is much more expressive than these markup languages. And so that's what we're going to be using as well, is just plain old C# code. So in this app host, so normally you have like the program CS that says, here's all the all the configuration and whatnot for an application. In my Aspire host, we now have this thing. Is this big enough for the folks in the back? I can bump it up some more if we need to. Yes, no? Good. Maybe, okay. Oh God, how do I zoom in this stupid thing? Appearance. 150%, okay. There we go. So when I want to orchestrate multiple projects together, the first thing I'll do is add a dependency from my app hosts to any kind of running application, running project in my solution. It's already been done here, so there is now a project reference for the NDC London CS proj. So it's already kind of a little funny, like I'm referencing this other project. But the only reason that exists, though, is for orchestration purposes. I will then, after this, say, OK, and now that I've added that reference, I say add this project, and this is a C# project as a resource. And this NDC London was just automatically generated by me adding that project reference. If I remove the project reference, it wouldn't know about that project. Every resource in Aspire needs to have some name, and so I give it a name, that it's NDC London. And now, instead of me running just the API, I'm going to run the Aspire app host instead. And when I run the Aspire app host, Aspire will run through all of my orchestration configuration, see how all the resources are connected together, launch them all up, in the order they need to be launched, and then eventually my API project will be launched as well. So let's just run now the Aspire host. OK, so this did launch something up. And let me switch over to light mode, and let's bump it up here. So right now, this is just a very simple Aspire application with one API. This is not complicated enough for me to use Aspire, but I just at least want to show you the different building blocks available to us. And so at this point, Aspire is the thing that has now launched my API. And so I can then go look at it over here. That's actually /swagger, or is it? Ooh, do I not even have a Swagger UI up and running? Probably not anymore. Oh yeah, just Open API. So I could go get the full like JSON of the Open API, but by default now, they don't even put in any kind of Swagger UI or scaler or anything like that. But it is running there behind the scenes, and I can go then look to see, oh, here's the log messages of the things going on. We'll dig into a bit more this thing here, this dashboard. That was one of the first things that I saw that enticed me about using Aspire, was having a single place that displayed all of my different resources, and then seeing all the different logs, and eventually I'll show you traces and metrics of all my different applications running. So like right away, this is a massive improvement on anything I had before. Having a single view of all the different applications that are running that isn't like like debug windows inside a specific IDE. My team is pretty diverse. I'm using JetBrains Rider just because I've always used it. But most of my team uses VS Code or Visual Studio. Now, Aspire itself does not require any IDE. You can actually just go CLI Aspire run, and it'll run this application. But now my entire team has a visibility into all the applications running on their local environment, as opposed to having like 16 console windows all launched up with Docker over here and all this stuff. It's like, no, it's just one view that brings absolutely everything together. So right away, it's like, OK, I want this because this is 8,000 times better than anything I had before to visualize and see my running system locally. All right, I'm going to stop this, and I'll switch over to a more complex application that does have a lot of different services that I pulled together. And I tried to just like check off as many as I could. I didn't do all of them because I'll show it in a little bit, but there's like well over 100 different resource types that you can pull in. It's not just projects and a database. There's tons of different things you can add as part of this. So I just pulled in as many as I could in the time frame of building out this demo and being able to show everything. But there's just a ton of resources out there that you can add as part of this. All right, so right now I've just got this single web application. And it's a little bit more complicated than the previous one because the previous one did not have any dependencies, any external dependencies. It was just an API that just said, here's the weather forecast. I wanted to spice things up a little bit at first. And so this one also includes database. So up here, we have in our entity framework, here it is, we have a DB context with an actual database. And so this database is using SQL, so it's just using Entity Framework Core SQL Server. So right away, if I'm trying to make my life easier for my team, or my team's life easier, my life easier, this is the first hurdle I have to cross, to jump, whatever. I need a database. And where should that database be? How should the database come into existence? And I've done like 24 different ways of doing local databases over the years. Everything from using SQL Local DB, which doesn't work on a Mac, so won't work for me, to of course, installing a developer edition of SQL Server on a Mac, won't work for me, to restoring a backup from production. Hopefully it's been scrubbed of data. So like there's just a lot of different ways, or migrations, database migrations to build up your database locally. But you need some way to get that database up and going. And in the past, the way this database has come into fruition for me is we would have some local build script that would build the database for local dev and testing in some custom way that was specific for my individual team. And every time I would go to the next team, I would have to have some new way of building out this local database because something was always different with this new team's environment. So we want to fix that. So ideally, regardless of the runtime of the machines, anyone that joins my team should be able to get up and running with a database and have data populated with it without having to do a bunch of extra steps or jump through a lot of extra hoops. So this is where Aspire is going to help us right away. Is Aspire will be the thing that we say, I need a database, and I need to connect that database to this application. So how do we do that? So the first thing we need to know is, well, how do I add resources to Aspire? How do I tell Aspire that there's going to be a database server and a database and a database inside of there called something? And the way we do that is by referencing NuGet packages in the app host. Every kind of hosting extension, every hosting resource is just an additional NuGet package. And there's a giant list of these. So I'm going to the Aspire website. This is just aspire.dev, fantastic resource for Aspire. You can go to integrations, and over here on the left is a list of all the different kind of integrations for all the different kinds of resources you may want to include as part of your system. So for example, databases. We have Entity Framework Core using SQL Server. I probably could have used Postgres because the Postgres images is like a tiny fraction of the size of SQL Server, but a lot of my clients do use SQL Server, so here we are. So yeah, there is a NuJ package for SQL Server, and then what we have here is integrating that also with Entity Framework Core. So like making sure the connection strings are applied properly, all that sort of stuff is part of this integration. And so again, okay, this says use Aspire, whatever, but really what we'll be using is package references. So we just have to add a package reference to aspire.hosting.something, whatever the thing we want to use as a resource is that NuGet package we used. Now I've already added those NuGet packages over here, and I'm using Central Package Management. Is anyone here using Central Package? Yes. Some side notes do use Central Package Management. It makes managing versions much, much easier. If you see here, there's no versions anymore in my package references. That's because they're all managed centrally in a single centralized list of package references. So I never have to worry about like mismatched package versions between projects anymore. It's all there. Anyway, aside over. And so I've added the package references for the different hosting extensions for what I'll be showing today. And one of them is going to be Aspire hosting SQL Server. When I add that package reference to my Aspire host, I can now include SQL Server as part of one of the resources that I'm going to connect into my Aspire host. So let's look at that. All right, so right here, I've got my resource for the database. And we have a few other things I'll be adding here in a second, so I'll come back to that. When we add resources in Aspire, again, it's just C# code. And so typically you'll have builder.add something, whatever that resource is. And in this case, it's builder.add SQL Server. There's some additional things I need to configure as part of it. I wanted to have a deterministic password. And so what I've done is added a parameter to my resource. And what this allows me to do is have, by default, if you don't supply passwords to these resources, they will get random passwords. But a lot of times when I'm developing locally, I might have some kind of SQL, Postgres admin or something that I'm connecting to that local database resource, and I don't want the database password to change every single freaking time. So I've got this parameter that says, here's this database password, and where does this come from? This actually just comes from user secrets. So if I go here to say tools, user secrets, I've got the SQL password, that's this one right here, coming in my SQL Server instance. There's other parameters here as well, but that's where that one is coming from. That's not the only location these parameters can come from. Parameters can also come from launch settings. So somewhere in here, it's got parameters for that. Or it can just be in local storage as well. So I've got a database password with a deterministic value that I know every single time I can connect, it gets the same thing every single time. So I've also got some other extra configurations here that are specific for storage-based resources. Normally, with Aspire, when you run the Aspire host, it will launch all your resources, And when you stop the Aspire host, it will shut down all those resources. But for a database, I don't want it to like go up and down all the time, because I may run my application and then stop the application, and then I want to go look to see, hey, where is, what does the data look like here? And so by saying, giving it a persistent lifetime, it tells Aspire, don't shut this down when you shut down the Aspire host, keep it up and running. This other piece with data volume, this is a more kind of Docker-specific configuration option. What it's just telling the Docker configuration to do is to use a data volume to ensure that whenever I stop and start the SQL instance, I don't lose all my data as well. That is also the default with any resource you have, is all the data just goes away. So you have to opt in to say, no, this one I want to keep the data for. Some of these are by default, they'll keep the data, but SQL Server is not one of those. You want to make sure the data sticks around and make sure the lifetime stays around as well. But contrast this with Docker Compose. I would have this and a separate Docker Compose YAML file with the SQL instance there, and then something would need to run Docker Compose up-d to launch up my images, my resources, and then I have to make sure I can connect to that from my application host. And in this C# code, I say I've got a SQL Server instance called just SQL with the data volume lifetime, and also a single database called SQL Data. So whenever the database starts up, it will create a SQL database called that. And now I want to connect this database to my host application, right? The API that actually uses the DB context to do some work. I need to connect these two resources together. Now, the way to do that, we will add a reference to the SQL instance. So this is the web application that I've added a reference to. So I added a reference for this web application to this app host. And then I say this project uses that resource. And so you do that with the with reference method here, that this method waits for that one. Now, one final thing that we can do that we couldn't do easily with Docker Compose, or really almost any other solution, is to ensure not just these things are connected, but also that we add dependencies between these such that I don't start things before their dependencies are ready yet. And so that's this final little component down here. I say wait for SQL. What that's going to do is wait for the SQL instance to be up and healthy and be able to respond to requests before it starts the web application. Just that one line of code, wait for the SQL, solves so many of my problems I used to have of like, oh, I forgot to run Docker Compose and the database wasn't up and running. Oh, wait, no, I stopped the SQL instance. Oh, Docker isn't running the thing anymore. Just that little like, wait for this thing to be ready before you launch yours, like eliminated all those sort of, like I can't connect to the database yet because the resource isn't quite there yet. So yeah, it's all just expressed with C# code. I say add this reference, wait for this reference, and now when I run the app host, I think that's all I need for this right now. The last little piece here is how does the web application know how to connect to the database server? In the past, in my web application, we'd have app settings JSON. We'd have something in here that is the connection string that's like, here's my local SQL instance, or here's my local Docker of SQL running. And it would just be a hard-coded connection string inside of here. Maybe it's here, maybe it's in user secrets, but it's something I have to explicitly add in to this configuration to make sure all those different pieces are connected together. But we don't need to do that anymore. Because Aspire is orchestrating these two resources together, it can, once it knows it's got the SQL instance up and running, when it launches the web application, it can inject configuration into that running application so that it will automatically get the connection information from the Aspire launched database. So in here, I didn't show it over here yet, but right here I've got use SQL Server, get connection string, SQL data. This connection string instance comes from Aspire launching the application and injecting that configuration via environment variables. Nothing magical here, just environment variables. But when it launches that application, it's like, oh, this thing depends on this, and it's a SQL-based thing, and you said it's an entity framework, so I know an entity framework likes things called connection strings. So I'm going to apply an environment variable called that so that when it launches the application, it just all gets connected together. So let's launch this now and see what we see. Huzzah! Oh, I have Mongo still. Well, whatever. we don't need Mongo yet, but we'll get it here in a second. OK, so what do I have here? I've got my SQL database, SQL Server instance, and the SQL database over here as well. And these are running inside of Docker. So this is why you do need to have an OCI-compliant Docker runtime so that you can run these external resources. It's all done through Docker. So that's where that comes from. I said I need a database called SQL Data. Well, that's where that came from, the SQL Data instance here. And finally, I have this web application. And the web application referenced the SQL Data database. So if I then launch up this Swagger, which I did put in place, if I go look at, let me just look at the controller here. Sorry, I'm still using controllers. I'm old school like that, whatever. This weather forecast API endpoint actually uses a DB context to get the weather data. So the other example was just like random data. This one is actually backed by a database with SQL Server using a DB context here. And so when I say get all my forecasts, now this time it's actually using the DB context. So let's run this. Weather forecast, try it out. Sorry, I've not switched this one over to use Scalar yet. Scalar's pretty. And it worked. Huzzah. It actually got out the API actually returned values that were pulled out from the database because you see these have IDs. So these actually were backed by rows in a database that were being pulled out again. And it's not random, so if I run this again, try it out again, execute, it's the same ID. So 92350, run it again, 92350. So yeah, same response every single time of getting this. So by adding the database resource in Aspire, configuring it just using plain C# code, and then connecting that resource over to my API that's running, I'm able to get those two resources up and going without having to do any extra work, right? It's just plain C# code, and my API itself is none the wiser, right? If I'm looking at this API that says, yeah, I just need a connection string called this, that's just regular .NET configuration code. There's nothing special. There's nothing in this web application that even knows that Aspire exists. Everything is injected into it via these environment configuration values, which when I go to deploy this application, yeah, okay, so that connection string may be stored in Key Vault. It may use managed identities, so it just has like a hard-coded connection string. I may use like actual different app settings.environment files to do that. What I do in like deployed environments is a different story altogether. This is really just about making my local dev life easier without compromising what happens in my production environments. So I don't want to affect production by introducing Aspire, and so this doesn't do that. I'm not changing how this application runs just by adding Aspire. It's just orchestrating and gluing these different pieces together. All right, so that was just a database resource. The next thing I want to add is something more interesting. What if my API has to talk to another API? So this resource talks to another application. And so what I've done is I've got another forecast controller, but this time, this one uses HTTP client to get those values. So first, I need to get the normal I need to get my strongly typed HTTP client. So that is, excuse me, this one right here. The external API client. This is just a Claude code generated API, strongly typed API client. And this is an API client. Let me stop everything. This is an API client for, over here I've got external APIs. So you can imagine, like, well, this API is running locally as well, but it could be an external API as well. But just to make my life easier, it's an API inside of here. So you can imagine, though, if you've got like an API gateway sort of pattern or BFF backend for front end, where we've got an API that composes other APIs behind the scenes, then those other APIs are also resources that you want to glue together as part of your full distributed application here. This API, though, was just like file new web API, and so all it has as part of it is this, just random weather forecast, whatever. But the thing I'm adding on top of this is Aspire. So I'm saying also add all those service defaults to bring in those components as well. So all the common logging, telemetry, resiliency, service discovery, those are all getting pulled in as well. Now, those dependencies, by the way, are not Aspire dependencies. They just make it work better because it's like, oh, you're in a distributed environment, then you probably want all this configuration to make that world easier for yourself. Not required at all to use Aspire, but again, it just makes my life a little bit easier to have this kind of default way of configuring these services. OK, so we've got this external API. In my this external controller now, I will get this right one time. This external controller now will use the strongly typed HTTP clients to make a call over into the other API. So it's just a facade, right? Just this, I hit this API, and it calls the other API to get the result back. This is like the dumbest thing that could possibly work as part of this demo here. So it's just a pass-through API. That's all this is. OK, so I need to configure this HTTP client, right? How does this web application know where this other HTTP resource is? It needs to know when you configure these strongly typed clients, you have to tell it, here's my resource name, or here's the host name to call out to with the port and all that stuff. So this one as well, I would like Aspire to manage those dependencies for me as well. So now we go over to Aspire, and what I'll do is I've added, in my app host, I added the project reference already to the external API. That was this one right here. And then in my external API, in my configuration for the Aspire host, what I'll be doing is adding the external API here as, again, a C# project reference. Oh, go away. As a project reference, and so it's a project-based resource. And so that's why I say add project, external API, and then I have to give it a name. So the name is just going to be external API. So by adding this resource, now I need to connect this external API to my web application. And I do that again with reference. So when I say with reference external API, now it will inject the service discovery information from that API over to my other project. So it knows that that is a web kind of resource, and will then inject the service discovery details so that when I want to call that external API, it will just know what the host name should be. So the last piece is to configure that strongly typed HTTP clients here. Yes. Boy, this is hard to see when the font's so big. So I have this strongly typed HTTP client, and I tell it that the URI is not like localhost : gobbledygook port whatever. Instead, we can use a well-known host name. So in this case, external API. In production, obviously that would be swapped out and probably done through configuration, right? Of like, well, use the actual real production API endpoints. But in this case, I just hard-coded it for this demo purpose. So I'm not using localhost. I'm not using ports. I'm using a host name, external API. So the other piece that Aspire will do is when you, by default, this is enabled as service discovery and service registration. It will create all the appropriate Docker network junk. I'm not a Docker captain, so I don't know all the right terms of all these things. but it will configure the Docker network so that this domain will be resolved when I run this entire application. So let's give it a go. I believe I got everything going. There we go. OK, so now I have the external API resource going. And you can see here that it's got like a little logo, an icon here to describe what kind of resource this is. So this is a relational SQL container thing. This is the SQL database. And these are the two C# projects we have here. I can run the external API by itself. Let's see, that is /scalar. But if I want to make my life a little bit easier, let's just see the call through as well. So I call this /scalar, and then I can execute this one individual request here. So then test it out. Send. OK, so yes, it got that stuff. So this is me hitting that external API by itself. Now I want to run that through the host web application to have it go to the web application, to the external API, and then back again. So that's this external weather forecast. And huzzah, it worked again. And so yeah, this is always randomized, so it's just every time I execute it, it's going to return random results. So I execute again. Now it's sweltering, lies, mild, closer. So yeah, it's by me adding the service discovery and connecting those two resources together, now it knows that these two things are connected and is able to do that service discovery to ensure that that external API hostname works correctly. Again, just a few lines of C# code to get this all up and running here. Now there was one piece here I still had commented out. So you notice when I clicked the URL that it didn't go to like /scalar or /swagger. It was like just the root. So one of the things that Aspire provides for us is the ability to extend that dashboard to do even more interesting things, such as customizing those URLs if you want to have multiple URLs that you can click on, or if you want to have, I'll show you in a second, even custom commands you can run from the dashboard itself. So let's add in a better URL in this app host. And we do that using endpoints. So what I've said is, yes, you do have like the root endpoint that is just the root, but there's nothing listening to that endpoint. So if I click it on the UI, it's not going to do anything. So what I said I can do is add an URL for the endpoint. I give it the protocol. This is just HTTP. And I can even give it better display text. So instead of like, just a full URL, I can actually have like display text for that link in the UI. Again, these are just small little things that makes using these kinds of distributed applications easier. Is now I've got, oh look, a more user-friendly way of seeing that scalar endpoint. I can click on it because I don't care about the port or anything like that. That doesn't matter to me. I just want to be able to quickly get to that the scalar UI here. All right. So in our list of resources here as well, we can see how things are connected together. Because Aspire orchestrates all these different components, we can actually see how all these different components are related together. So we've got the web host references the external API. This web uses the SQL data that is on this SQL server. So we can see, because it's all, as Aspire goes through that distributed application startup, it knows how everything is connected together. You can't get this from like Docker Compose, right? Docker Compose typically only has the resources, your dependencies. It won't necessarily include like every application that you're running as part of this. All right. How else can we extend this dashboard? One of the things that I often have to do is run commands to do certain activities. So oftentimes I'm having to go switch over to my CLI. If I want to do something like create a new migration for Entity Framework or run migrations for Entity Framework, it's always me having to go out to some other thing to do the work versus having like a nice interface to say, I just want to add a migration for this resource or perform this action for this individual resource. So you can do that with the Aspire dashboard as well. So over in my database resource, I want to add a custom command to run the database migrations for Entity Framework. Now, this is something that Maddie and team, Maddie's the PM for Aspire, they know like this is not super clean looking, this like external commands. So they're like they're iterating on this to make it better. But right now it is like very much a old school way of doing it. When I want to run database migrations, which is .NET EF database update. And so you have to basically use like the process, kick off a process to run this command, and then you wait for it to be done, and that is the result of the process. So when I'm configuring this command, I need to give it a name. So everything is always a named resource inside of Aspire. I give it some display name, and then I say, here's what you should do as part of your work. So I'm just going to take whatever I was running from the command line and then port it over into like this code here. And finally, I want to give it a nice little icon name or a nice icon in the UI. And so this uses some icon library to do it. And so you go look up what's a good icon for this. And I said arrow square upright. Sure, why not? So now I'm going to rerun the dashboard. I've got my web application, the external API, the SQL data. And now if I click this little ... here, I've got migrate, a custom command to run the Entity Framework migrations. So what could you do as part of this? Well, the Aspire configuration also lets you have user input. So if you wanted to add a migration as part of this, if you're like tired of going to the command line, you just add a command, say I need a text input, and feed that into running the command. So if I click this, it says starting. Succeeded. Well, there's no migrations to do. But if I go look at the, over here, the console, oh, where would it be? Oh, no, it would be in the database. So that was the SQL data. There he is. So yeah, because there's the SQL data resource I ran this action under. And so yeah, if it actually ran, like it actually migrated the database, then you'd see those different migration scripts here. So what have I used this for? Like we use this for this. I'll show you here in a second, but we would also use it for NPM. So Aspire, let me just switch to that then. Aspire does not require you to have C#.NET based applications. I think right now they've got like 7 or 8 different runtimes that you can use as part of it. And so if you have, I've got a React app and an API, you can also connect both of those via Aspire. And so that, again, is just yet another hosting package to pull in. Over here in Aspire, I go integrations, and then I just search NPM. Usually just search for the thing I'm looking for, NPM. Oh, look, JavaScript integration. So there is a way for us to say, builder.add JavaScript app. Oh my God. I would always have to have a separate console window up and running where I was doing npm run dev or whatever the npm thing is, I don't even remember. And I was always this like really janky one development environment for JavaScript-based stuff, which is all like command line stuff. But if I wanted to run the JavaScript app with the API, because I always run those two together, it was always this like sort of two-step process of I'm over here running this, I'm over here running that. You don't have to do that anymore. You can run both your NPM application and the API and the database and the Redis cache and everything that's part of it can be all part of the Aspire host, the Aspire host runtime here. So things I would do as part of this as well would be, well, yeah, run the NPM application, of course, so I can launch up the React front end or Angular front end along with the API. This also allows us to, because these are all Aspire resources, how does my React front end know how to connect to the API? Again, because this is all orchestrated via Aspire, I can inject into the Node application when it launches the URL for the API as well. Because again, it's all part of this one single distributed application host. This is a somewhat new addition. So when Aspire was first launched, it was just .NET based. So if you looked at it a couple years ago, you're like, well, that's great, but I've got a bunch of other resources. So at this point, though, that's not the only, it's not just .NET runtimes. It's all of these. Go, Java, Node.js, Orleans, sure, if you're doing actor-based stuff. So they're continually adding more and more of these frameworks and runtimes so you can orchestrate all of these different kinds of resources together in one single application host here. All right. I don't have an NPM app as part of this example because I'm not a JavaScript developer. I wasn't even going to attempt to clod my way through this. So I don't have that, but yes, it is a thing that exists that you can put as part of this. Now, the last thing I want to show here are some of the more advanced features of the telemetry aspects of Aspire. When I first got started with Aspire, I was looking at ways of replacing a bunch of different local observability tools, and Aspire also provides that as well. So I would have to run locally like Seek and, or maybe not Seek, maybe it's like Logstash, Grafana, and then Zipkin. So every single client had their own like cobbled together set of observability tools to be able to peer inside of a more complex distributed application that I'm trying to run here. So one of the other things that Aspire has for us is an OpenTelemetry compliant server to collect telemetry data and then to display it to the end user. You will see this and you will wish that this was what you had in your environments because it is so much better than App Insights or almost any of the tools I've used out there. This dashboard, telemetry dashboard, is miles ahead of those things. So to get those all up and running, this leverages OpenTelemetry. So I won't go a lot into OpenTelemetry other than to say it is the standard for observability, collection APIs, reporting APIs, everything observability is under the umbrella of OpenTelemetry, and Microsoft is a huge proponent and contributor to the OpenTelemetry effort. So this team, the Aspire team, instead of being like, let's invent our own new way of doing telemetry data to be able to see what's going on in my application, instead they said, well, let's just use OpenTelemetry and have a really nice UI on top of it. So I've turned that off right now for this application, but I'm going to turn it back on here. OK, so that's actually going to be in my service defaults. So in my applications, so each running application is generating telemetry data underneath the covers, but doing nothing with it. So I want to do something with that telemetry data and have it show up inside of the Aspire dashboard. So I've turned it off, but let's turn it back on. Oh, it is on. Never mind. So yes, as part of each running application, OpenTelemetry is something you need to opt into to turn on because collecting telemetry and generating telemetry can be an expensive operation depending on like where you're pumping that data into. So you don't want to necessarily have it turned on by default. If you're in Azure, though, you probably don't even know this, but when you deploy an application into like Azure App Services or container apps, whatever, the Microsoft cloud, the Azure cloud, will inject the App Insights connection string. And deep inside of ASP.NET Core, there's something that looks for that environment variable and then will turn on Application Insights telemetry automatically. So you may not have known that when you deploy to Azure, that the reason why you have the App Insights dashboard working is because they've hard-coded that inside of ASP.NET Core to like recognize it and pump that data out. So that doesn't exist for OpenTelemetry. We have to explicitly turn this telemetry on. Whenever you create this service defaults project, that's part of the things that are put inside of there is turning on all this telemetry. So I want to add OpenTelemetry logging, OpenTelemetry tracing, and then OpenTelemetry metrics as well, and then add the default OpenTelemetry exporters. So the collection of it is all these standard OpenTelemetry APIs, which are Microsoft packages. There's nothing special here. And then the exporting, that protocol is also a standard as well. To how does my application push telemetry out to something? In this case, it's the Aspire host. That's all a standard as well. So you could swap this exporter out for in production, app insights, or whatever. And so that's likely often what you see as part of this. But what I wanted to show was just the Aspire dashboard aspect of it and how it makes these kinds of complex distributed systems so much easier to understand and debug without having to have an expensive IDE to show you this information. So I think everything's ready to go, so let me just go run this. All right, so we're gonna execute again our API here. So this Swagger endpoint, this one talked to a database. So I'm gonna call this one, and then this one talked to the external API. So I'll do that one as well. And now I go over to my dashboard. I didn't done that yet, but over here you have resources, and then you have all the kind of telemetry outputs of your system. This is all, again, 100% standards-based OpenTelemetry, so we could point this telemetry at anything else that is compliant, which is, I mean, just about all the different telemetry providers, the observability platforms are compliant with this. But this one, it's all running locally. So if I wanted to see, well, this API called this API called this database, that's pretty challenging to do if I just have console windows. So here I can see, oh gosh, okay, here's all the junk that was going on as part of doing all this stuff, right? It's, okay, well, I called the one API, so that was this one, web, right? Web. Well, okay, so yeah, oh, there's a client handler, so there's something there. There's some stuff here too. It's like, oh, listening here ran this. So just having logs means I have to Humpty Dumpty this thing back together again. And so with OpenTelemetry and tracing and Aspire dashboard, I can see this full trace of these different, requests going through, instead of having to just have 16 console windows open and try to figure out how these all relate to each other. So I do have structured logs as well. So if you're familiar with Seek or Serolog, this has structured logging as well as traces. So I've got those two requests I made, the get weather forecast and the external one. So in this one, we had the get that talked to the database. And as part of that, I can see the database statement that was being executed and the duration. So all the normal stuff you would see like in App Insights, I now have available for me here locally instead. What was the other one? External weather forecast. So this one was an HTTP request. So I called a get here and made this get request on the web app, and then called this external API to get that as well. So I can see the full trace we have going on here. I don't have time to show a more complex example, but if you've got messaging, if you're doing pub sub with events and things like that, this will all be consolidated into one single view here that's all connected via OpenTelemetry in this lovely little dashboard. This dashboard, by the way, does not need to be run as part of the Aspire host, app host. There's also a standalone Docker container that you can run as well. So if you want to say, for your lower environments, like dev or whatever, dev, integration testing, whatever, and you don't want to muck around with App Insights or whatever, you can actually run this dashboard inside of those as standalone, and you won't necessarily see these resources because it won't know about them, but you will see all your logs, traces, and metrics that are all now able to be searched and all the stuff that you see here. Now, the final thing I want to show quickly is, what about my existing applications, my existing systems that may be using Docker Compose or something like that to do its stuff? So in terms of how I migrate an existing application into using this, the first thing I do is just go find to see if there is an existing resource for whatever that is already existing. So if there's already a NuGet package for you to use, great. That's not always the case. Sometimes there is not a package there. There's just a Docker image. So I want to show that as my last little demo here. I wanted to use, this application was originally using Zipkin for the tracing viewer, but there's no Zipkin resource available for me in Aspire. So if you've got, like this, a complex set of Docker Compose, what I'm looking for is is there something that already has this kind of resource? But if not, if there's not that resource available for me based on what I see here in the Docker Compose, then what I can do instead is just use a plain container-based resource. So right here, you can just say, I want to add a container with this name, with this is the container instance. And of course, there's all sorts of other parameters here. You can give it the tag you want. And then it lets you configure like basically the stuff that you would see in running Docker or running Docker Compose. It's all this kind of C# code instead. So even if you've got like an existing ginormous Docker Compose file, you can just move all of those sort of configuration options into C# methods here. And then using the references inside of the app host, you can then connect your application resources to those Docker resources or SQL resources or whatever. So if you have any more questions about this, the best resource I have out there is going to be the aspire.dev website. That's got extensive documentation. It's a very well-written, well-thought-out set of resources. Otherwise, if you have more questions, I'll be hanging out afterwards to answer them. And otherwise, I hope you have a great rest of the conference. Thanks for coming.